Hey everyone, so I had a good suggestion to kind of replace what we used to do in regular lecture of going through some of the sapling problems and some samples like them and so on, to give you a little more guidance about how to work those and how to apply what we're learning to the problems. So I'm going to start with homework 8. There was a request for a few of the problems from that, and then I'll start doing this preemptively for the remaining 2 homework assignments, right? So I'll give you one that has at least guide to how to get started for all the problems, or most of the problems. Okay, so starting with number 3 on homework 8, and the problem says, the version of it that I have here says that there are 9 uncharged capacitors, all with equal capacitance. So I'm going to write down the info here. So we get 9 capacitors, all with equal capacitance that we're going to call C. And they're connected and they're in series. And there is a battery that has a potential difference across the terminals of the battery that's 6.39 volts. Okay. And it says that in the process of charging them up, Q is equal to 0.0002, they should use exponential notation here, 247, and it's coulombs, which is unfortunately another capital C, so I'm going to just write out the word coulombs for now, and in a minute I'll leave off the units and just, have you remember that. Okay, so that's the situation, and the task of the problem is to find C, right? That's our goal, is to figure out what C is. So the first thing that's worth looking at here, let me draw a little schematic here. So here's the battery. So that's the 6.39 volts. And there's a bunch of capacitors and they're in series. I don't think I'm going to draw all 9 here. And notice, maybe you've picked this up from the reading of the lab and stuff, but just to make sure everybody's clear on this, right? So if you have a battery, the symbol for a battery is the negative terminal is the short end, and the positive terminal is this longer end. It looks a lot like a capacitor, but that's a battery. This one is a battery. These ones are capacitors because the plates are, at least to the extent that I can draw accurately, the plates are the same length, right? So that's what the symbols are meant to represent. Okay, and so you've got a whole bunch of capacitors here, and I'm just going to do that so that I don't have to draw them all. There are 9 of them, and that's the setup of the circuit, right? So that's C, that's C, that's C, right, times 9. Okay, and so, the usual approach to solving a problem here, we look at this and we say, what do I know that can help me access what I don't yet know? So something I'm going to write down, first of all, is I'm going to notice that if I think about this circuit as a whole, right, all of this, I can replace, I have 9 capacitors in series, and hopefully you remember, or you can look up from the notes, that there's a formula that we have that when you put capacitors in series, there's a relationship that I can replace as if there's a single equivalent, that's the EQ for equivalent, capacitor that's related to the individual capacitors by this formula. And again, there's going to be plus a bunch of these. There are 9 of them. So that's the same thing as saying that 1 over equivalent capacitance is equal to, there's 9 of these, so 9 times 1 over C, so that's just 9 over C, right? So another way that I could write that will be useful here is I can write that equivalent resistance is equal to C over 9. I'm going to kind of file that away. I said resistance again, didn't I? Sorry, capacitance. I've been working on the lab, which is on resistance. Okay, so, all right, so next, what we can do here is we can say, all right, so is there any other way that I could express the equivalent resistance? And it turns out there, said it again, the equivalent capacitance, and it turns out that you can, because the problem gives us the charge, right? So the amount of charge that's on one of these plates, and hopefully it makes sense that if I take the charge, if I put, say, positive charge on that plate, I must have taken it from that plate, right? Because this is just a wire here. So to I can move charges around. I could take, say, a negative charge and pull it using the battery, pull it off of here and put it onto here or whatever. So the charge just reflects how much, like it says in the problem, how much charge moved through the battery. So I have Q, and I also have the overall voltage of the whole thing. So that means I can write that the equivalent capacitance is also equal to just, from the definition of capacitance, it's Q over V, but that's just, now I am going to use scientific notation, 2.47 times 10 to the minus 4 divided, and that's coulombs, divided by the 6.39 volts. So now I have two expressions for the equivalent capacitance, and this one I can solve for, right? I can just, that's a number, and I can stick that into here, and then that leaves me with a number over here, a number down here, and then the capacitance that I'm looking for there, and so then I can solve it and get the answer that I'm looking for. Okay?